TNO in the Netherlands proudly presents INVIS, the Integrated Night Vision Surveillance and Observation System. The portable sensor system is mounted on a rugged all-terrain platform and provides dynamic and color-fused multispectral imagery for surveillance and observation applications. The portable sensor suite of the INVIS system is contained in a water and dust resistant housing. It contains a long-wave infrared microbolometer sensitive to the thermal part of the spectrum, an intensified visual camera, onboard data storage units, and an intensified near-infrared camera. It also has two onboard displays for real-time monitoring the sensor signals of the individual bands. All three cameras are optically aligned, looking along the same optical axis through a single aperture. The INVIS system has different applications. This video shows the registration of an actual daytime reconnaissance mission. The inset shows a real-time mapping of the system position on a Google Earth map. Since the system can operate in all lighting conditions and has an all-terrain capability, it can be used to inspect buildings, for instance. The system also can be used for remotely piloted or autonomous reconnaissance missions both in daytime and at night. And because of its all-terrain capability, even the most rugged terrain is no problem for this machine. The system can also be used for mission preparation, since the synthetic scene generator allows virtual driver walkthroughs through an environment before actually going into the real environment. We will now show the registration of an actual nighttime mission along the same route that was previously inspected in daytime. This time, armed persons are moving across the scene. They clearly show up in the thermal image, shown on the lower right, but they do not appear in the intensified visual and near-infrared imagery, shown on the lower left and middle, respectively. The color-to-night representation on top clearly represents all relevant details in the scene and provides a better sense of depth. This recording was made at night, in complete darkness. The sky was largely overcast, and with the naked eye it was hardly possible to distinguish any details, especially the persons hiding in the bushes were impossible to perceive. Note how well the vegetation is represented. It lights up nice and green. Recent technological developments enable the application of color-to-night in compact portable devices. This allows the deployment of color-to-night for dismounted surveillance operations, as shown here. Note how well the sky and the vegetation is represented in this image. As a comparison, we here show a standard night vision goggle image. It's much harder to distinguish details in the scene because they all have the same shades of green. Here we show a situation in which the INVIS is used as a local area surveillance tool at night. Clockwise you see the standard night vision goggle image, long-wave infrared thermal image, which shows clearly the suspect escaping. On the lower left you see the virtual environment, and on the lower right you see the combined color-to-night image. The virtual environment can be used to inspect the area around the building, to locate possible hiding places and escape routes for the subjects before actually going into that area physically. The INVIS system can also be used as a building inspection tool. When there is reason to believe that the escaping subject may have entered the building, the virtual representation can be used to inspect the inside of the building, to see where the entrance signs are and where the subject may be hiding. Here you see, for instance, a simulated bomb hole which may have been used by the subject to enter the building. The system can also be used to remotely inspect buildings both in daytime and in nighttime. Here we show how the color tables that are used to produce the color the night representation can be changed real time. Different applications require different color mappings. For instance, urban reconnaissance requires an optimal representation of man-made objects like buildings and streets. Search and detection requires a representation in which visually camouflaged targets pop out. Navigation requires a representation in which roads clearly stand out against water or grass. The color tables can be swapped in real time. It's an operation that requires no computational effort whatsoever and can be done on the fly in real time. The system also has different real-time image enhancement procedures. Here we show the effect of contrast enhancement and noise reduction on a dynamic near-infrared image. The upper left part shows the original near-infrared sequence and the upper right shows the image sequence after contrast enhancement. The lower left shows the effects of noise reduction and the lower right part shows the effect of contrast enhancement on a noise-reduced version of the sequence. Small details are much easier to discriminate in this enhanced representation. In this example we show how the virtual representation of the environment can be used to select an optimal viewpoint. First we scan around the environment to determine where possible subjects may have been hidden and what the possible escape routes are. Then we use the virtual environment and take a bird's eye view of the environment, project the viewing angle of the camera system into this environment and determine what the optimal viewing direction and viewing position of the camera may be to produce the optimal image. Then we use the virtual representation to inspect certain selected locations, like this house. We can remove the walls to view the inside of the house and to determine where subjects may be hiding and what possible viewing locations they may use. We can inspect the building from all sides and from the top. In this example we show how subjects try to escape from a building using a smoke grenade. First, a smoke grenade is thrown. You see in the lower left visual and the near-infrared image that it's very hard to distinguish this man in the scene. In the thermal image you clearly can see the man, but you cannot see the smoke. And in the combined color night image you can both see the smoke and the man at all times, with a correct representation of the colors of grass and vegetation and sky. Once the suspect has disappeared behind the building, the virtual representation can be used once more to classify the terrain and determine its trafficability, for instance by determining where water and roads are. This concludes our presentation of the INVIS integrated night vision system. For any further information, please contact TNO in the Netherlands.